You've seen it in the movies. A warship out in the middle of the ocean, enemy incoming, and then, instead of a missile, a flash of pure electricity, a projectile hurled at the speed of sound times 7. No explosion needed, just raw, terrifying kinetic force. It looked like the future. It sounded like science fiction come to life. And for 15 years, the United States Navy genuinely believed they were building it. They spent $500 million trying. And in 2021, quietly, almost embarrassingly, they stopped. No battle, no enemy, no dramatic last stand. The railgun just died in a lab. This is the story of the most ambitious naval weapon America ever tried to build. The one that was supposed to change everything. The one that changed nothing. The dream. Okay, so first, let me actually explain what a railgun is. Because honestly, the concept is brilliant. Forget gunpowder, forget rocket fuel, forget all of that. A railgun works on pure electromagnetism. You have two parallel metal rails, picture train tracks, but smaller. You run an absolutely massive electrical current through them. We're talking about 1,000,000 amps. 1,000,000 amps. That current creates a magnetic field so powerful, it literally throws a projectile down the barrel and out the other end. How fast? We're talking Mach 7. That's 7 times the speed of sound, about 5,400 miles per hour. For comparison, a bullet from a standard rifle, Mach 3. A typical naval shell, Mach 2. The railgun blows both of them out of the water, literally. And here's the beautiful part. At Mach 7, the projectile doesn't even need an explosive warhead. The kinetic energy alone is so enormous, it destroys everything it hits. Pure physics doing the work. Range, 100 nautical miles. That's roughly 115 regular miles. Conventional naval guns can barely do 13. Cost per shot, about $25,000. Compare that to a standard Navy missile, which runs anywhere from $500,000 to over $1 million per shot. You can see why the Navy was excited. You can see why in 2005, when they officially launched the program, they thought they were looking at the future of naval warfare. Velocitas erratico, speed kills. That was the program's actual Latin motto. They weren't wrong about the speed part. The promise. The year is 2010, 5 years into the program. At a naval weapons testing facility in Dahlgren, Virginia, engineers gather around a railgun prototype. Cameras ready, sensors live, everyone holding their breath. They fire. A world record, 33 megajoules of energy, a projectile fired with a velocity of over 2,500 meters per second. The room goes wild. Admiral after admiral visits the facility. Congressional briefings happen. The Navy starts talking openly about fielding the railgun on ships by 2016. There's even a plan for where it'll go: the Zumwalt-class destroyer, America's most advanced warship, a 600-foot, 15,000-ton stealth ship built for exactly this kind of next-generation warfare. The Zumwalt was designed with massive electrical generation capacity, perfect for a gun that needs 1,000,000 amps to fire. It all fit together perfectly, almost too perfectly. And then, slowly, quietly, the cracks started to appear, where it all fell apart. Here's the thing about brilliant ideas. Physics doesn't care how brilliant they are, and the railgun had a physics problem. Actually, it had 3 physics problems, and every single one of them was a killer. Problem number 1, the barrel. When you fire a railgun, the temperatures inside the barrel are absolutely insane. We're talking hotter than the surface of the sun for a fraction of a second. That heat destroys the barrel every single time you fire. In early tests, the barrel was essentially destroyed after just a handful of shots. Engineers worked for years trying different materials: copper, specialized alloys, experimental composites. Nothing lasted long enough. A naval weapon that needs its barrel replaced after a few shots? That's not a weapon. That's an expensive paperweight. Problem number 2, the power. Remember that 1,000,000 amps I mentioned? Generating that much electricity in the short burst required to fire, that's an engineering nightmare. The power systems needed are massive, heavy, and technically complex. Even the Zumwalt ship, literally designed to generate huge amounts of electricity, struggled to provide enough consistent power for reliable railgun firing. And here's the cruel irony: to fire the railgun fast enough to be actually useful in battle, say 6 to 10 rounds per minute, you'd need even more power than the ship could produce. So the gun that was supposed to replace expensive missiles could barely fire once every few minutes. Problem number 3, the range trap. And this one is almost darkly funny. The railgun had a range of about 100 nautical miles. Impressive, right? Except modern enemy anti-ship missiles, they have ranges of 200, 300, sometimes 400 miles. So, to actually use the railgun against an enemy ship, your ship would have to sail inside the enemy's missile range first. You'd be bringing a super fast gun to a fight where the other guy already has you in his crosshairs from twice the distance. The weapon designed to keep American sailors safe would have put them directly in harm's way. 15 years and $500 million now. Here's where the numbers get uncomfortable. The Navy started this program in 2005. Through every budget cycle, year after year, money kept flowing. $28 million one year, $15 million the next, $9 million after that. They knew the problems weren't getting solved. Senior engineers were raising red flags. Budget analysts were asking hard questions, but the program kept going. Why? Because stopping a program is hard. There are contractors involved, jobs at stake, political interests. The sunk cost, all that money already spent, makes it psychologically difficult to just walk away. Sound familiar? We talked about the same thing with the M10 Booker in our last video. By 2021, not 15 years in, the Navy finally pulled the plug. Total cost, over $500 million. Railguns deployed to actual warships, 0. Battles fought with it, 0. Enemies threatened by it, 0. $500 million, and it never left the testing facility. The twist nobody expected. Okay, so here's where this story takes a turn I genuinely did not see coming when I started researching it. While America was quietly canceling their railgun program, Japan was quietly building one, and not just building, actually succeeding. In October 2023, Japan test-fired a railgun from an actual warship, a moving ship at sea, something America never managed to do in 15 years. They hit Mach 6.5. They fired over 120 rounds without destroying the barrel, by switching from copper rails to a specialized metal blend. Total cost of Japan's program? $6.5 million. Let me say that again. America, $500 million. 15 years. 0 ships equipped. Japan, $6.5 million. 7 years. Firing from an actual warship at sea. That's not a gap. That's a canyon. And then in February 2025, something interesting happened. The U.S. Naval Surface Warfare Center quietly resumed railgun testing at White Sands Missile Range in New Mexico. No big announcement. No press release. They just started again. Turns out they're using the railgun now as a research tool, testing materials and sensors for hypersonic weapons. The gun that failed as a weapon is being recycled as a science experiment, which is either very pragmatic or very sad, depending on how you look at it. Is the railgun actually coming back? Here's the thing though, this story isn't fully over. In December 2025, President Trump announced a brand new class of large surface warships, the Trump-class battleship, and among the weapons listed for it, an electromagnetic railgun. General Atomics, one of the original railgun contractors, confirmed they never actually stopped working on the technology, even after the Navy canceled the program in 2021. They kept going quietly, on their own, and the Trump-class ships are being designed with much more powerful electrical generation systems than the Zumwalt, specifically to handle weapons like railguns and directed energy systems. Could the railgun actually work this time? Maybe. The barrel problem. Japan may have cracked it with their metal alloy research. The power problem. The new ship designs address it directly. The range problem. That one is harder. Enemy missiles keep getting faster and longer ranged. But here's the argument that's gaining ground. A railgun shot costs $25,000. An interceptor missile costs $1 million. If you're defending a fleet against a swarm of cheap drones or cruise missiles, firing $1 million missile at a $10,000 drone is a losing equation. A railgun that can fire 10 shots a minute at $25,000 each? that math suddenly looks very different. What this really teaches us. So what do we actually take away from all of this? Not that America is bad at weapons. America has the most powerful military in the world and some of the most brilliant engineers on the planet. The lesson is simpler and harder than that. Great ideas need more than great science. They need great engineering. They need realistic timelines. They need honest assessments when something isn't working, even when billions of dollars are already on the table. The railgun wasn't a bad idea. At Mach 7 with a 100-mile range and $25,000 shots, it's a genuinely brilliant concept, but brilliant concepts have to survive contact with reality, with heat, with physics, with the enemy who isn't standing still while you figure out your barrel erosion problem. And maybe the deepest lesson of all? The objective was never the railgun. The objective was always the capability. Fast, precise, lethal. If hypersonic missiles can deliver that capability better than a railgun, then the railgun served its purpose just by showing us what was possible and letting us find a better path to get there. Sometimes, the most expensive failures teach you the most valuable lessons. $500 million, 15 years. A weapon that hit Mach 7 in a lab and never once fired in anger. The Navy's railgun is one of the most fascinating stories in modern defense history, not because it failed, but because of what that failure actually meant, and where it's quietly leading us next. If you want to understand the real story behind the weapons, the failures, the billions spent and lost, and what it all means for the future of warfare, this is the channel for that. Hit subscribe, because next week, we're going even deeper.